So in this session, we are going to discuss few example about the delta modulation so that we can better understand. We have already discussed delta modulation in our last session. So in this session, we are going to discuss few more example about the delta modulation. The example one, a DM, a delta modulation system, is designed to operate at sampling frequency of 6 kHz and step size of 350 millivolt. You need to determine the maximum amplitude of a 1 kHz input sinusoidal signal for which the delta modulator doesn't show slope overload. And second point, you need to determine output SNR. So let's see what are given. Here you can see the sampling frequency f of s is given, which is 6 kHz, and the step size delta, which is 350 millivolt, is also given. And in first one, if we are discussing about the first part, is the for the maximum amplitude, the signal frequency of the FM is also given, which is 1 kilohertz. So Fs is 6 kilohertz, delta is 350 millivolt, and the FM is 1 kilohertz. And the condition is that you need to see which is the maximum amplitude, so that the modulator doesn't show slope overload. We need to see what should be the maximum amplitude. So we know the condition to avoid slope overload, the AM should be less than equals to delta of Fs divided by 2 pi Fm. So all the values are given. So we just use those values here in this equation. So delta is 350 millivolt, 315 times per minus 3, Fs 6 kilohertz, 3 6 into 10 raised power 3, 2 pi is constant, Fm is 1 kilohertz, so 1 into 10 raised power 3. If using the calculators we calculate, we can see that AM should be less than equals to 0.3357 volt. So if you want to stop overload, it means that the A value of AM should be uh, like this. The second point was determine output SNR. So if you want to determine the output SNR, the formula for that is 3Fs cube divided by 8 pi square Fm square multiplied by W. Here you see W is not given, so we can calculate the W from the sampling rate, because sampling rate is equal to 2 multiplied by W, and W is equal to sampling rate divided by 2. So sampling rate divided by 2, sampling rate is given, which is 6 kilohertz divided by 2 is equals to 3 kilohertz. So you are giving 3 kilohertz. So use all the values here in B. So 3 into 6 into 10 is power 3, 8 pi square, and Fm is 1 kilohertz. So 1 into 10 is power 3 whole square, and W is 3 kilohertz, or you can see 6 divided by 2 into 10 is power 3. So using the calculator, you can calculate its value, that is 2.77. But if you want to calculate in dBs, you can use this formula 10 log 10 and 2.77. So if using a calculator, you can take log 10 of 2.77 and then multiply it by 4. The answer is 4.42 dB. So let's have more example. Let a message signal xt, which is equal to 6 sine 2 pi into 10 raised to power 3t plus 4 sine 4 pi into 10 raised to power 3t, be the input signal to the delta modulator system. Then you need to determine the minimum sampling rate that will prevent the slope overload if the step size is 0.314 volt. So what is given? Signal is given and the step size is given. So xt is given and the step size is 0.314 volt. And we already know that to avoid the slope overload condition, delta of Fss should be greater than. If usually the signal is given in term of function, then we better use this formula, because the xt is given in term of function. So we better use delta multiplied by sampling rate, which is greater than equals to d by dt of the function xt, max value of xt, if you're taking the derivative and the maximum of that. So this is left hand side and that is the right hand side. So but you need to determine this sampling rate, so which is f of s. So in left hand side, delta f of s, delta is given 0.314 and then multiplied by f of s. Keep it as it is because f of s is unknown. Then second is right hand side, which is d by dt, and xt is 6 sine 2 pi into 10 to the power 3t plus 4 sine 4 pi into 10 to the power 3t. If you take the integral of this part, you know it will be 6 and 2 pi into 10 to the power 3, because this is extra term 2 pi into 10 to the power 3. So if it is extra term in derivative, it will be you are writing at the front in front of that, and the derivative of sine is cos 2 pi into 10 to the power 3t plus 4. So this is also extra term 4 pi into 10 to the power 3, and the derivative of sine is cos 4 pi into 10 to the power 3. And we know that the maximum value of cos is 1, so that is why, so we can replace this whole factor cos 4 pi times 3t by 1. Similarly, we can replace this factor as well, cos 2 pi times 3t, with this 1 as well. So 12 pi, 6 to the 12, 12 times power 3 multiplied by 1 plus 4 for the 16 pi times power 3, and then 12 plus 16 is equal to 28 times power 3. So this is the right hand side. If you take this right hand side and insert in this formula, left hand side and right hand side, so you can see that the sampling frequency should be greater than or equals to 28 pi divided by 10 raised to the power 3 divided by 0.314, so which is equals to 280 kilohertz. Sampling frequency should be bigger than 2 kilohertz, so that it will prevent slope overload. Let's have a few more examples. Consider an analog input signal x of t, which is zero point 0.1 sine 2 pi into 10 raised to the power 4t. For a DM system, the signal is sampled at a rate of 2 into 10 raised to the power 4 Hz. Find out whether the slope overload distortion occur for the following step size. The step sizes are given, and then you need to see whether the slope overload distortion occur or not. The first step size is given 4 millivolt. So here you see this FM is also given, which is 4 10 raised to the power 4 hertz, and sampling frequency or sampling rate is also given 2 into 10 raised to the power 4 hertz. Sample data rate 10 raised to the power 4 hertz. So which is also known as 20 kilohertz. So you can write this as 20 kilohertz. To avoid slope overload distortion, we know already this formula delta into Fs, which is bigger than d over dt x of t of max. So delta FFS is equals to 4 times power minus 3, and the sampling frequency is 20 into times power 3, which is equals to 80. And now on the right hand side, which is that one, so the answer of the derivative of that one, point 0.1 is already there. This is extra term 2 into 10 to the power 4, so into 2 pi into 10 to the power 4, and the derivative of sine is cos 2 pi into 10 to the power 4 t. So zero point 0.1 into 2 pi into 4 10 to the power 4 into 1, because we know that the maximum value of cos is always 1. So this is equal to 2 pi into 10 raised to the power 4, the right hand side. So from right hand side you can see it is 2000 pi. So the left hand side is 80 pi. So this condition, the condition written in A, is not satisfied. So from 1 and 2 it shows that condition A does not satisfy, so the slope overload will occur. So let's discuss the second step. The second step was the delta step size was different, which was 60 millivolt. So 16 to the power minus 3. FFS is 20 kilohertz. So the answer is 12,000. But you can see the right hand side was 2000 pi or 1200. So that was 2000 pi. So again, you can see from 2 and 3, the condition given here, this condition does not satisfy. So again, the slope overload will occur. So that's all. So we have already explained few examples. So I hope that you understand these examples very well. So we will try to discuss few more examples in our next session. So please be in contact Um, please be subscribe as well so that you can watch our new videos about the few more examples. Thank you for watching the video, and if you have any question you can write in the comment box. We will try our best to answer the question.